Welcome everyone. Let me share my screen. I hope everyone can see my screen. If it is yes, then please confirm me through chat box. Okay, cool. Okay, fine. So from today onwards, we are going to start from our Docker, and the course is actually designed for master into Docker, Kubernetes, Terraform, Helm, and monitoring tools like Prometheus and Grafana, and continuous delivery tool is ArgoCD. And who are all not attended yesterday's session, just please go through the YouTube channel. You'll get a video over there. We just discussed some of the basics about the course, and so this is how the structure that we designed yesterday, how the real-time use case will be. We took some use case and we discussed this is the diagram that how the connectivity will happen and what all the tools will be involved here. Okay. If you see from the left to right side, from the left and including left shift testing and also from the right shift testing, okay, so everything will be going to be covered in this course, which will give you almost 3 years of experience with this content. You can just focus as of now is something, and from now onwards it is something else, okay, because these are very important tools in the market. And if you are a DevOps engineer that you want to prove yourself, then you should must know these tools perfectly. Okay. Recording is happening with it, don't worry. And who are all Priya, you can find the link, you can find the video at the YouTube first 2 to 3 sessions, and then we can find in our classroom, Google Classroom. Okay. So let's get into the topic. Okay. Let's get into the topic. And we are starting from the Docker. So who are all not attended yesterday, I'll just give you some information about the Docker. So basically, Docker is a containerization tool that we all know. If you are learning DevOps, then you should must know this definition, right? Docker is the a containerization tool. But why it is came into the market and what is the importance of it and what actually it is serving the features into the market or into your DevOps lifecycle or at your production, what it is doing exactly. Let's understand that. Okay, let me clear it out this one. Yeah. So first of all, what we know something a server. If you want to deploy any application, that you have to create one server. You have to create one server. Inside the server, you need to install an operating system. This is host operating system where bins and libs will be also configured along with this. Okay. You have some CPU configuration, memory configuration. It's a bare metal server where you have some your host OS. And top of this, you're going to deploy and your application. Okay. Here your application bin on top of your bins and libs, your application will work. So this is what the general case we know. But if I want to install or deploy these kind of multiple process running applications into one server, how can I do it? how the resources will be shared. So this server is something an 8 GB or 20 GB. If this 8 GB you're running three different applications, how this 8 GB and four vCPUs or CPUs is going to be shared to your application process? That is a difficulty. At your direct server, you can run direct services by connecting the application. By connecting the application, you directly run it. But how many services are equally going to run, and how much these applications are going to be reliable on the server? No, it's not at all. You can also give it a try. Take 3 4 Java Spring Boot applications or any .NET applications. I try to run it over the server. How many you're going to run? Directly you can connect with the server actually without using any web service. Web service is nothing but Nginx, Apache, IIS. All these are Tomcat. All these are web service tools. Without using a web service tools, you can also run. Yeah, without Tomcat also we can run the codes that you are directly running the jar into the server. Try to run a jar, you can directly connect a server. Try to run a npm without any web service. You are just building npm build, npm start. It is connecting with the server, right? You are doing the Python. You're just doing Python 3 run and app.py. It is running with the server. You're directly connecting the application with the server. Okay. So that way you can run. But how many you can run? The resource has to be equally need to be shared between multiple process of applications. So it's not going to be happen as effectively that what you're thinking at the development area. So that is just for the POC, not for the production. Developer can do, or while we discussing these classes, we can also do. It is just up to us only. But when we go on to do in the production, we are not able to do that. It's not highly effective. There you will get a lot of issues. Your business will bring down easily. Okay, so that is an issue. So to avoid this, what came? There is a technology came, virtualization or hypervisor. Now just take it as an application. So this application, I would like to test it. I would like to test it. To do a test, I have to uh, I have to do that. Let's say Chrome, Edge browser, Chrome browser, Firefox browser. Three browsers. I want to do this. Application is running or not. This is a web application, let's say, or any Android application. You need to create stimulators on the Android, Apple, and other. Okay. For this, what I need to do, I have to create three servers. Three servers. So one server is for Chrome, one server is for Edge, and one server is for Firefox. And then I will be deployed here, here, and here. Once you deploy, then developer will also able to check this application. Manual tester will come and they will check the everything and they will write the report cases. And this is how it will happen. But here you are utilizing the hardware, right? Here you are using the more compute resources, which is costing you very high. For just small things to be done, get done, you're using this all this. This is a previous case before a Docker. You have to deploy all this. So instead of this, I can eliminate the server. Can't I use the same server? You can use same server. For that, you need to install hypervisor. Hypervisor V or virtualization VMware. Okay, kind of thing. Then on this hypervisor, again, on top of this hypervisor, type 1 and type 2, you are again going to run guest operating system. Guest operating system. On guest operating system, again bins and libs will be their dependencies, libraries. Okay, bins and libs. Here you need to write guest operating system for each of your VM. So this is one VM, this is one VM, and this is one VM. What happens here when you do like this, in the single server, you're distributing out of 8 GB, you're distributing 2 GB here, 2 GB here, 2 GB here, 6 GB is enough. On top of the host operating system, you're installing virtualization, and on top of that, you're again installing the guest operating system. Here you can install Linux, here you can install Ubuntu, here you can install RHCL. Here it is a Chrome, here it is a Edge, here it is a Firefox. Then you can deploy your application and do a test. So with single server, you can get done this work, right? You are saving the computational resources. So which saves you a lot at your organization and data center and cloud also, which saves you a very lot of money. So, but there is a challenge. It's not that easy that we are discussing here. Running a guest operating system, just install a one virtual machine at your laptop and try to create one. You need guest operating system again. You need an image, Windows image. You need to run it and you need to do a configuration. You need to share the resources. So here, network adapters, network identifiers is a problem. You need to get a correct network identification. And this application, whatever you deployed, it has to be accessed outside. So these are the some of the hurdles that we face when you do with the virtualization at the single server. Okay, a server virtualization. So these are the hurdles. And if you want to move this, you want to run this particular virtual machine in another server, it's not that easy. You need to shut down. You need to again create one more. You have to do a configurations. So this is a very big work, headache work. It's not a simplified way. It's not in a simplified way. To make it simplified, even though this all these things are from LXC, LXD, RKT, okay, we have many containerization techniques. These are the RKT, LXD, LXC or containerization techniques. Even though we have, but why Docker is become a popular? It is just making your life very simplified way. So that's what we call containerization. Containerization. So what is mean by a containerization again? Now if you take the same server, if you take the same server, you will be running one host operating system. You'll run one host operating system. On top of host operating system, you'll going to install Docker. Then it is going to enable some Docker layer for you. Network, Docker network. Okay, that's it. You can now run your containers. You no need of guest operating system. Okay, now you can run your containers. And these containers are nothing but running a virtual isolated instances. Simple definition. Running virtual isolated instances or servers. Instance means we discussed already, right? Server is having many names. Okay, so it's a instance. And here network communication will be very easy. Network communication will be very easy with your host IP address. If you have host IP address 192.168.1.12, you can access these containers with the port numbers. But what is the case in this virtual machine? So something is different. Okay, here also you can do port bindings and all, but quite different configurations. Rather, you're comparing with the Docker. It's something quite easy to do these configurations. And You are making it like packaging the image, Docker image. I'll tell you what is a Docker image also. You are packaging the Docker image into a tar, and that image, nothing but bins and libs, and you are extracting and running it as a container here. It's very easy. You can kill it also. You can run it in another server. Moving this container to one another server is quite easy with the Docker. So your application you can install here, you can test it out here in this container like Chrome, Edge, and also at your Firefox. To get very good clarity, so let me open some factor app methodology. Whenever you see any application that you want to deploy, so these are the things that you need to consider. First is a code base, dependencies, and configurations, and then your DB, cache, and attached resources, and then you have to build, release, you need to run the stages and the process, port binding, and while your process is running, scale out via from the process or scale in via process, okay, and disposability, and if you are running over for test lower environments and production, logs, and admin process. These are all the things that we need to consider when any application is running. These all things can be very easy with your Docker. All these things are very easy with your containerization technique. Let me tell you that how this is going to be work again. That we know we already discussed right now. What is a container? It look like a virtual, walk like a virtual machine, or runs like a virtual machine? No. So it is an isolated instance that is going to work with sharing the kernel with the separate network stack, process stack, IPC stack. Let me tell you, Docker is already like it's developed based on the kernel sharing with the help of C groups and namespace in a server. How it is developed? It is by using the term methodology and the technique C groups and namespace in any server, Windows server, Linux server, you take any server, it is there. Okay, that's how your Tomcat is running. That's how your RHL or OpenShifts are. They utilize the case and they just developed very high level. And Docker also, like your JBoss also, everything all using the same concept. If you see, this is a server where you need hardware, operating system, bins and libraries, and then you can install the app. This is how I said direct connection with the server. And when you come into the virtual machines, virtualization, type 1, type 2. In type 1, where you can see on-premises data centers, hardware, host OS, hypervisor, and top of that guest OS, bins and libs and dependencies you are installing, and then you can run your application. And if it is a cloud native, hardware, hypervisor already installed, you can install guest OS, bins and libs, you can run the application. Okay. But when it is compared to container, as I said, just hardware, host OS, you can just run your things in the container. So this is how the containers look like and how the container Docker will work. As I said, it's going to work with C groups, namespace, and those going to be copy and write is equal to Docker container. This technique in these three techniques in inside a server, you can compare with the Docker containerization technique. Okay. So this step we called as ixs-start. It's nothing but docker run command. Nothing but docker run command. What happens at the C groups? Kernel feature, group process, control resources like your CPU sets, memory, IO, disk and all at C groups. Any server, Windows server, Linux server, any server, this is mandatory. There are some namespaces which is going to be a bridge between your process and your namespace. Namespaces are like your process IDs, net IDs, namespaces, IP stacks, and your mountings, MNT namespaces. Okay. So this is very important. Without this, none of server will not work. None of server will not run also. This is what the kernel sharing will happen. Based on this, now copy and write image. What is an image? Image is actually bin and lib. It's not a file system. It's not a VSD. It's not a anything. It's just going to be bin and libs compressed with your tar file. And it is having a hierarchy with arbitrary depth. So always your arbitrary will work inside the server. If you take any Windows server, any DLLs you are invoking or ingestion, that the arbitrary will work. This is the behind process I'm talking, which is fit into the Docker and Docker registry. That's how we can see now containerization technique. We're not building anything right now, it's already built it. We are just going to use it. So this is something a history about the Docker container I'm telling. How this is evaluated, how it is came. Okay. So by these techniques, the Docker container is created. Now installing a Docker and doing containerization is quite easy. Okay. If you see at Windows and Linux, how the things will work. At your C groups, at Linux, it is C groups and control groups having a job objects. Namespace having PID net IPC, and here it is having the object namespaces, process, table, and networking. And here it is something VFS, and here it is UFS. So this is how it works. And there are some key components I would like to tell you in Docker. One is Docker images, Docker container, and Docker registry. Okay. What is mean by a Docker image? A image is nothing but ready only template. But I don't recommend this, even this definition also. I'll say Docker image is something packaged your bins and libs with dependencies of your source code. You can tell like this in real time. If someone is asking you in the interview, just so don't say that Docker image is a image and Docker image is having something, all these things. No. Docker image is something, it's a packaged image. It's a packaged image, even though it is nothing but a tar. Okay. It's a packaged image which combining of bins and libs, dependencies and source code. That's what we need to tell. Okay. And how this image, what are the prerequisites for it, and with what sources it will build an image. We need to understand that. This is a primary component that we need to understand. As of now, we learn the importance of the Docker, right? And in continuous, we are going to learn about the Kubernetes also on top of this. So to maintain and orchestrate the container, we need the Kubernetes. So I covered that one into yesterday's session. Just please go and check in the yesterday's session that I have given introduction about all the tools that we are going to cover in this course. So let me discuss about the Docker image. When you have your source code, you have a types of deployment, right? We've seen that you can directly deploy this or you can package it and extract it. But in a simplified manner, uh, to get done your work effectively, we are just doing containerization. So we have a code. What do you do? Even though you have your Docker containerization technique, you will build image. you build your packages. Which packages? You're going to build some DLL packages or EX packages or some Py packages or jar packages, var packages, any package you are developing according to your code. Okay. So this package is mandatory, and people are who are telling you that direct doing a Docker image, even though direct doing Docker image, it will build actually. In real-time organizations, there are two ways of building this. Okay. What happens in the building case, you are building a package. Let's say you are building a package. This package is a var package. Just for an example, I'm taking. It's a var package. So this package has to be containerized. This package has to be containerized. You are building this package and then you are going to be for containerization. Sorry, Docker imaging. Okay. Here in this case, you're going to do a Docker image. So this package, whatever you are building in this package, already everything will be there. Everything will be there. And before Docker, you're just skipping and you're just deploying this package into a server. But now what happened? So this package is going to be inside your Docker image. Inside your Docker image. And this Docker image will have your package dependencies and everything here with your dependencies and all. This one, you're going to run it as container. You're going to run it as container. So inside this package is going to be, this image is going to, let me take the image now. Okay. Now it's converted into the image. Okay. It's going to be converted into image. This image is going to be in the container and it's going to be extract and run as a service. Service is nothing but your application. Remember, always in real time you're going to call it as not the application. You're going to call it as service. Inside the container, whatever is running, you're going to call it as service. Okay. And here inside your container, your service will run. Okay. And we have a technique, one more technique, that in order to deploy this container and image and all, that is Helm. Okay. So what we do once we deployed this container, to maintain this, we are going to add one more layer on top of this container. Add one more layer top of this container is nothing but pod. Nothing but pod. Okay. So this pod is again I can call it as a running virtual isolated instance, which it holding a container inside service. So Kubernetes is not replacement of your Docker. What Kubernetes? Kubernetes is not directly having a mechanism or ability to maintain the container or to control the container. To do, you cannot apply those kind of features over the container. That's how Docker Swarm failed. That's how Docker Swarm is failed. It's not highly effective, that the feature that we need according to the business. Kubernetes is added this layer and it is orchestrating, nothing but managing your Docker containers in terms of reliability, in terms of load balancing, in terms of scaling, nothing but auto scaling, horizontal and vertical. In terms of do this, the Kubernetes is highly recommended. Now the world is running on the Kubernetes. Okay. So Kubernetes is going to use on this top of the container. To create this pod and to run this container inside, there's a one more technique called that is Helm. Okay, that is Helm, which is easy for us. Helm technique is making you easy to deploy the Kubernetes. Okay, now this service is nothing but your application. It can be a backend service, API, front end, but not a database. Remember guys, container is not a database. Database is always going to be a cloud native service. It can be RDS, Mongo, Postgres, something is service you're going to use. A container is never going to be a database for your production applications. If that is the case, then that is a POC or something your staging environment things only, but not into real time. Real time, you'll not see the container as a database. Database is always going to be a service in the cloud, native service in the cloud. So that we need to know. So we have to know how to connect this containers with along with the Kubernetes to the database side. We have 5 types of services in the Kubernetes. For just to share the information, we have external names, headless, load balancer, cluster IP, and node port. Okay, 5 services we utilize. Yeah. So if you understand by seeing the diagram, a pod is a added top of layer over your container. Kubernetes is not having an ability to directly maintain the container, so that's why we are adding the a pod. A pod, it is a separate network that enabled over your container. It is a network. This layer, whatever you're seeing, it is an isolated logical network on your container, and in this pod you can run your container service, your container and service. Inside this pod, your container will run. Inside the container, service will be run. And your Kubernetes is going to maintain this pod. Your controller, scheduler, kube API, proxies, stateless, stateful, daemon sets, ingress, services, everything is going to work on pod. If the pod is working, inside container is also working. No. If your pod is works, but sometimes container will not work. That is the case. That is the real time cases. Pod, okay, pod is showing up and running, but the container will not up and run. It will fail. You need to check. Where you need to check? You need to check with your building image. First thing. Second thing is you are with your environment variables or something configurations and all. But you have to check with your source code, build, and Docker images. It is something vulnerable and all. You have to do a Docker scanning as well here. Scanning. Okay. So these are all the things will be involved, and once your pods are running, later things like your ArgoCD and Grafana promises, those things will come into the picture. Now let's understand from Docker imaging. Now just keep in mind, Docker image is nothing but your source code is going to build a package. That package, yes, here also we're going to cover scanning as well. So this package is going to convert into a Docker image. So as a part of your CI/CD pipeline, as part of your CI/CD pipeline, what you're doing here, you're doing Docker image building with the help of Docker file. Okay, we'll discuss that with the help of Docker file. Okay, so this image is going to extract and run it as a service in your container. This is the technique, which is very easy. Now Let's understand the Docker architecture. If you see here, Docker image, some definitions, Docker containers, and Docker registry. That what we need to know. So how the Docker works? Docker works like this. So Docker previously, at the time of 2017, Docker is actually employing much into the market. But that time, client and server are separate at your on-premises. Client and servers are separate. But how the technology is growing and the techniques are growing, Docker became something that where daemon and client will work at server only, at togetherly. At that time, most of the interviews who are Linux administrators who worked over the data centers and all, they are just into the same mind. Uh, Client servers are different. I need to communicate. Two servers are different. Network has to be enabled and all these things. Blah blah blah. But that is not the case. If you go to that subject again, you will block into that subject only in terms of data center. But now everything is cloud optimized. Now we are not into a data center. You're not even finding the data center jobs except network engineers. Okay. So here your Docker client and Docker daemon, nothing but Docker engine and Docker hub. These three components are very highly important to run your Docker environment. So Docker client is something that is always going to communicate with you and your daemon, Docker daemon. Let me tell you. So if you see Docker logo, what is a Docker logo? If you see Docker logo, it is a ship. It is a ship, nothing but a server. And inside there'll be a host and you have a engine here. On top of that, you're running the containers, right? Inside the container, there'll be a different things, right? Stuff. So this can be a cars, this can be a bikes, this can be a footwear, this can be a clothwares, and this can be some scrap, this is some iron, right? So there are different things inside the containers. Your boat is carrying all this, but different stuff inside the containers. This is the same thing. And to drive this boat, to navigate this boat, to maintain this boat, what we need? We need a steering, right? That is going to be handled with the engine, that is Kubernetes. That's how whenever you see the logos also, the logos are same. It's inspired from these things, techniques only. Okay. So this is Docker here. So here your daemon. So whenever you're going to be communicate, your daemon is going to be communicate. And there's a hub. What is hub? Hub is where everything is get stored in the Docker registry. So related to Docker, we have images, libs, bins, or any other packages or any other plugins or any other infrastructure architectures. We need it to run the Docker environment as everything is available at the Docker Hub. When the Docker is developed, it's an open source only. Okay, you can use free of, and we do have a Docker enterprise also. But in the open source or enterprise, you're going to connect with the Docker Hub only. So openly, they have given many of the things in order to run your Docker environment. If they not give you open source, this is the not the world now. Because containerization is makes human life very easy. Okay. So this is a client and the daemon and the Docker Hub. So what happens in this previous case that what we are discussing, when the packaging this Docker image happens, we are going to maintain this into a Docker hub. Docker hub. So as a backup, and whatever you need to run this package, and you're going to download from the hub. It's a to and promotion. It's a to and promotion. You need the things you can download from the Docker hub, and whatever you developed, you can keep a copy of the image securely at the Docker hub. Okay. So not only Docker hub, we are going to utilize our own organization repositories with JFrog, Nexus, S3, and ECR, ACR, and GCR. Okay. This is how this image will be. Now, let's understand some basics about the Docker. You need to know about the Docker commands almost. If you want to do a practice at the Docker, you can do at the AWS cloud. Also, you can do at a free platform called Killer Coda. If you go type Killer Coda and click on this interactive environments, play with Docker also one of the free environment that you can do a practice, but let's do a practice here. You just go to the playgrounds and take one Ubuntu single environment server, log in with your GitHub, create them. No, I don't want them. Start it. Oh, it is telling you are using unsupported browser, use Firefox or Chrome. Issues. Yeah, so it is enabled a server for you. You can use it. You can also increase this one or no. You can increase it here actually. Font size 4. You can see Docker version. Docker already installed here. So there are three ways of installing. You can run Docker over your on-premises server directly, or you can also run with your docker.io or Docker package installation, like apt install Docker and apt install docker.io, and you have different packages: snap, vmc, and dnf. Like this we have many. I'll just share you that, don't worry, when we go with our uh, server over the AWS. But if you see Docker images, now this is a client. Now in this server, Docker is installed. In this server, Docker is installed. If the Docker is not installed and you're running Docker images command, it will not detect it because doesn't server doesn't know it. So what happening here? When you install Docker, the client will enable, and whenever you give this instruction Docker images, this client is going to communicate with your daemon, and it's communicate with the server, and then it will give you this output: repository, tags, images. Nothing is there. Let's tell you that nothing is here. We can also do practice at our AWS cloud. Let me go and log into the cloud. Let me save it. Let me do authentication. One more code. No, no, no. That is gone. As I said, Tomcat is not the production one. It's just previously developer friendly tool at 2010 or 2011, 13, 14 time. But now it's not like that. Tomcat is nothing. Tomcat is just a simple, normal thing. Okay, you're not using it production grade tool. It's not a production grade tool. Hmm. It's single solution application, kind of LMS or very low web archived files. Like it doesn't need a much highly computed resources. In that case, you can use. Is you're not regularly getting high traffic. There's a specific traffic. Let's say in a day, that application will get highly 50 to 100 requests. Web archive file is enough, right? Is that application how many users usually get in a day? Can you tell me that which type of application it is? You said right, the application we are deploying on. Hmm. Hmm. Yeah. Hmm. 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 Since they don't want to disturb the old hierarchy, so they're following that. Yes. Hmm. Yeah. So I'm connecting to the server. So always you need to do apt update if you log in any of the servers, mandatory to do. Okay, here you can go with apt install docker. If you do like this, the package is not available at the this apt packages. So you have to do docker.io -y. Then it adds the Docker to your system and then it will install from your the apt package. Okay, now you can give Docker images. So nothing. But if it is the case of Linux, you need to start the service. But in Ubuntu, it's not like that. Since the package you downloaded and running, it will run. Okay. So now I'm not having any image here. I just want to run a application. For example, any application you take, I just want to run an application. So this is client and I already installed daemon engine inside my server. And where is the hub? You just go and search for Docker Hub. Here your Docker Hub. But in the case of your enterprise projects, sign in the place of your enterprise projects. So this is the not the case. Let me log in. It's going to be always your ECR, okay? And oops. So this is Docker, and at your organizations, developers are mostly having Docker desktop. This is an application. Before they going to hand over their feature branch to a DevOps engineer, or before they're going to give the feature branch commits towards the pipeline, they do building at their local environment. So Docker Desktop is the tool that is going to run in the Windows developers laptop, and then it will help them to build the solutions. So most of the times, all the microservices, so each microservice is need to run in the containerization technique. So developers also is going to build all the applications with Docker Desktop while they're going to run with Visual Studio or with Visual Code or any PyCharm or any other IDEs they are using. So they will going to run through your Docker Desktop. Some of the companies are taking the enterprise license of the Docker Desktop where they enable environments inside. Okay, let me show you how it look like. Docker Desktop. See, so this is how it look like, and it is going to run. And you can also install and you can do practice at your laptop with this Docker Desktop application. Let me open it. So it is starting. It is going to use my resources only. Now it is a kind of virtual machine tool. Okay, it's a kind of virtual machine tool. See, there are already some images in my Docker, some microservices, news feed, front end, some front end. Okay, some containers are already there 29 days ago, and here we can see containers. Right now, none of the containers is not running. Volumes, build, Docker squat. It is one of the scanning method, and see status failed completed. Okay, so with this Docker enterprise, like Docker desktop enterprise, your developers are going to work, guys. It's something same like your virtual machine. Okay, so let me do sign in so that I'll be up to date with my tool. Okay, now fine, cool. Now you can do your practice at your terminal as well. See, now I'm not into my anywhere like Docker images. If you type, see, it is showing the images here. Docker PS, which you can see for containers. None of the container is not running. If I run this containers I can able to see some application. Okay, just give you, let's come through the server and then we'll run it out. If I come to my server, I'm not having any image here. You can develop your image from the source code, or you can also call an image which is already available. But at your real world case, you will be going to create the Docker image. You'll be going to create a Docker image. Whatever the source code developer giving you, the CI/CD pipeline itself, inside the CI/CD pipeline, it is a part of creating the Docker image. So let's learn manually and then we'll go for the CI/CD. So that time you will understand very clearly. I don't have any image right now here. I just want to pull an image from the Docker Hub. If you go to Docker Hub, here you have the Explore option. Click on the Explore option. You have many Docker file like images in terms of machine learning, okay, in terms of trending this week, in terms of many things you'll be having. Okay, if I go to any of the Docker images, here you can see all these images are present. Okay, see it here, products, image, extensions and plugins, Docker official image which Docker is developed. Verified publisher means someone is developed but Docker officials are verified and then published. Sponsored OSS means open source, where they'll do development and they'll come here and they'll do a marketing in this hub. So this is how these three types of images are available, and you can see the category wise as well here. In the category wise, many of the things like your API management, content management, data science, language frameworks, machine learning, network, all types of images are available including your architecture. It is 864, 886 and 64, ARM 64, IBM browsers, what? Okay, have all the types of images. If you click any one of the image, click on Nginx, it will tell you all the things. To create this Nginx also, there will be a some code. There will be a some code. From where I can find this Nginx code? Okay. If you come down, you will be having supported tags for respective Docker file links. Click on this, open a new tab. You are coming to the Nginx official GitHub where this image is running. This is a Nginx tool. The tool is open in the Docker Hub. This is where the developers are contributing here. So this is the latest tag 1.27.3. We already discussed release, release process, tags in our GitHub classes, right? See, here it is a Docker file. Okay, this is Nginx tool. This image is already developed here, and this image we are utilizing and we can run it. And here some of the option that you can see to run it. Okay, same way if you come and go for your other web service HTTPD, you'll find the same. There'll be a, it is Docker official image, and if you click on this, you'll able to see the repository. Now if I want to bring this image to my server, how can I? Docker pull HTTPD. The command is already there. If it is Nginx, then it is an Nginx. Paste, pull it. So it is going to pull with your latest tag. Now it is pulling. When it is pulling, you can see this IDs. These IDs are nothing but your Docker image layers. And this digest is something where a unique identify your Docker image. And what it is telling, you can see IO library. As I said, Docker image is bins and libsite IO library where it is added with latest. Okay. Now you can give Docker images. Docker images. Now the image is ready here. The image is ready here. Okay. But what I can also call Nginx, let's say. Nginx. So there is already someone written code and that code is converted as an image. That image I'm pulling to my server. Okay, at your real-time organizations also, you are going to pull some base images. I'll tell you that. Some base images. Now my HTTPD and Nginx are my base images. To understand the process, let's go with the Nginx now. Okay, I have images. If you see, it is having 192 MB and 148 MB. Okay, so this is image ID and this is the latest tag. This image and this image I would like to run it as a container. So docker run -d -p. What I'm telling, docker run is nothing but -stat process, right? As we see in the PDF. So it is a process of starting your C group kernels, C group namespace kernels to write on convert into an image. Docker run -d in a background mode and -p. What I need to do? I need to do a port forwarding, port bindings. I need to do a port bindings. If you are confused with it, if you don't know how to do this, simply go to the Docker Hub and come down, and here you can able to find commands. Here you can able to do find the commands. So what is mean by a port binding? Okay, I have a server. I have a server. Inside this server, I'm running three containers. Three containers are nothing but three applications. Three containers are nothing but three applications. So in these three applications, I have only one server, right? One server will have only one IP address. Let's say it is 12.14.5.6. Whenever you access one public IP, you can only access one server with one process. But I have 3-4 services running, nothing but my containers. How can I access them? Since I install the Docker in it. So what do you do whenever you are running inside a server any container? Whenever you run any server any container, the container will have one port number. The container will have one port number and you can expose with another port number. So now the container is exposing on, let's say something 8080. Okay. So this container, because your Docker image you're exposing through the 8080. Now your container can work on 8080. So while the traffic is coming from outside and this container is working on something called 2024 and this container is working on 2025 port number. We also discussed, like old students are also, we also discussed that port number is a way of communication. This container is running on this port number. So if I access one single public IP, then none of the container will not access. How can I get access? I have to do a port binding. So this is very simple with the Docker. If not, in the Linux, you have to do a configuration separately. You have to run at least 7 to 8 commands to do this for each service. So what you have to do, by running the port forwarding, port binding command, this 2024, if it is listening, this is a container port number. When the traffic comes from the outside towards this IP address, you can give it like colon 2021. So 2021 will come to your this container. Outside, when you are accessing the server, you are accessing the 2021. But inside, what happens? So this is going to reach to the container with this port number. The request will come to this one with this port number. And you are going to run another one, like another port number with 1552, or another port number like 3000. So this one will access here, and this one will access here, and this one will access here, like this. That's how you can see here. While you're running -p 808080, 8080 is where your container port is listening, and then host port is from outside. Host port is from outside. This is port binding. That's why it is very easy in the networking terms. Docker is very easy in the networking. What we can do, I'll just say 8080 colon 80 or 80. Okay, you can give like this and give your Nginx image. Enter. Now it is run and created a container ID. How can I see containers docker ps? Now my docker container is running. My docker container is running. How can I check? We can see here ports. From internet, see the arrow. From the internet, 0.0.00, 8080, if somebody searched, then it will come to 8080 TCP of the host. Then it will reach to the 8080 of the container. This is how the communication. If I come to my cloud and take the public IP address, (8080), go to security group, only 8051, 22, all 443 are there. Let me go to it, edit inbound rules. I just want to delete all the inbound delete groups and add rule, all traffic, save it, come here and do it. My browser is not supporting or what? It is not secure. HTTPS. Let me run the container with a different port. Eight zero 80. Now it is came. Welcome to Nginx. It's just a sample Nginx that it is running. Okay. But actually what happens? If you have a source code, let me take a source code. Source code need to accessed as a Docker container. First, go to any source code. You can take any source code. For an example, I'll just take an example of we can do static or dynamic. Static websites download. Go here. Take any one of the application code. It's a static websites. Just it's not a dynamic. You can copy the link address and come to the server. And what I'll do, mkdir, I'll create a app demo. Okay, app directory. cd app directory ls. Nothing is there. wget. I'll give this link. So it's downloading the code. This is the code, zip code. Now I'm going to unzip this. apt install unzip. I have to install this package and unzip. Okay, ls. So it is got unzipped. You can see. If I go to this one, I'll be having the code. You can see work.html, js, index.html, images, css, category.html, about.html. Like this, some source code which developer usually write this kind of files. Okay, so this is there. So this code I have to convert into a Docker image. To do this, I have to use Docker file. Now here we need to understand what is a Docker file. Docker file is a technique of converting your source code into a Docker image. Into a Docker image. Into a Docker image. So this is Docker file. So what we write in the Docker file? We write some of the instructions. Like what? From instruction. This is very important. From. We are calling or borrowing one base image. Base image is like something where it is your server only. Keep in mind it is like server only. If you are calling base image as Ubuntu, already we are on the Ubuntu server. You again calling a Ubuntu image. Inside the Ubuntu, you have to install your application and do the process. What's the need of it? If you go back to 3 years back, this is what the case. But Docker also has developed many things, many packages, many images in order to support the development environment. If you are working for .NET, you can use SDK. If you are working for Java, you can use JDK or JRE. If you are using for NPM, so Node.js, you can use NPM. If you're using for Python, you can use Python other and Alpine. Like according to the programmatic environment, Docker already developed those kind of runtime images. We call what? Runtime images in order to save the execution time. While your code is running, it will take a lot of time, right? You have to install the dependencies, like how I installed unzip just before. Like that, you have to install. So for that, you need to add multiple run instructions. How many times you add run instruction, that many Docker layers will add into your container. So from is something your server, your base image. We call what? Base image. Keep it in a mind. An interview must question. In one of the interview, one candidate don't know, is just showing up a lot of experience, but is doesn't know that what is the difference between a already runtime base image and normal base image. Is asking a question like, why can't you take a Ubuntu? Why are you taking a JDK? Foolish. It's create a lot of Docker image space. The image uh, MB will be more. Whatever you're seeing Docker images here, the image size will be more. Then what is the point of your doing the containerization technique? We need to run application as soon as with less resource and less space. That's what our motto, right? So that's why base image is always very important. Okay, first base image, and here we're going to write some of the instructions like copy, add. Before that, we are going to, I'll just tell you about this. Don't worry, we are going to have the classes on this. Work dir, and we're going to have run. I want to keep run in the after from, and I want to keep work directory in the last. No, it's not like that. We need to follow some sequence in the Docker file. Okay, run, then expose and cmd and entry point. These are the instructions that we write in the Docker file. We need to understand very clearly. Now, writing a Docker file is also developer responsibility. Writing a Docker file is DevOps engineer responsibility. It's on both. Okay, it's on both. When a source code developed, Docker file must and should written by a developer. If that not works, DevOps engineer can fix it. But creating a file, writing a file, always remember developer duty. Okay, keep in mind. But if it is whatever, he will write a very sample file and he'll say, hey, it's failing. Then DevOps will come into the picture because Docker file is failing in the sense CI/CD pipeline is failing. It's our responsibility that time. Yes, we need to know a clear about the Docker file. So these are the instructions that we are going to focus. Just a small demo. We're going to understand from tomorrow this one. So I'm going to create a Docker file. Always D should be a capital. And here you can add some instruction. I don't know how to add. Don't worry, everything is possible at your Docker Hub. You just go and you're having this HTTPD, right? Just copy this. You can say create a Docker file in your project. Copy this, come here, paste here. And I am using copy, copy instruction here, right? I'm using copy instruction. So you can just keep it like this. Escape shift colon WQ explicit mark. Now the Docker file is there. I'll tell you what this Docker file is doing. Now the technique is I am using from as a base image of HTTPD this image. If this image is not here, it is going to download. Okay, it is going to download into the server. And then what are all the files are there, this is going to copy into this path. Now I have to create a image. Docker build-t. Actually, we have a buildx. Buildx is going to work behind the scene of buildx. Okay. We can also make use of make, scaff, cold. One more process is there tool we have, but Docker is mostly usable one. Makefile is the one, like we can use make also. Previously, still many projects, if you go to UK or US, they're still having their own traditional methodologies. They use make. You people don't know. I'll also give you a demo on this. Make files for development. Okay. There will be some clusters. There will be environment. Make file. Okay. So make we can use and we can also run our applications. Something like Docker only. Okay, we can build Podman, this make, and one more also there. I'm not able to recall this. But buildx is the one that is going to work behind the scene of Docker build. And -t, you have to give a tag app and then dot. Dot what? This dot, this buildx is looks for your Docker file. And whatever the instruction you give, it's going to be execute. Okay, we're going to learn in deep about the Docker file, don't worry. And if you're not, then you can give -f and the path. If it is something inside /app something, then you can give -f and the path. But now it is dot and enter. It is going to build your image. See, it's builded. When you type Docker images, you will be having your app image. You can see 149 MB, 8 seconds ago. App image. Now I would like to run it. Docker run -d -p. What I'll do, 2024 colon 80 app Docker ps 2024 80. You can see internet 2024 80 and it is running properly. When you not provide any name to your container, it will take a random name for your container. Okay, you just come and give a 2024 to your IP address. See here, I already running Nginx, right? And I'm also able to run an application here. You can see you can hire a freelancer here. About get code. Okay, so like this is just a static website. It's a very static website. We are going to deploy dynamic websites, and we're going to connect with the databases. We're going to see the microservices. We're learning containers in the sense all are microservices. Okay, we need to know about the microservices first, how the microservices will be connect and all. You can see here I have multiple containers already at my local. Yes, here you can see multiple images. If I run all these containers, you can see front end and all. Okay, uh, if I run all these containers, run. Let me run first front end. Front end, run. It use my, see, 8080. It use my ports and all files and stats. Let me go to images and then I'll run front end. Newsfeed I'll run. Then I'll just come to I ran 3, right? Let me go to uh, random names it came. Let me identify. Which one is the front end? This one is the front end. Click on this. Debugging off. Okay. If I go, there itself it will showing you 8080 when you run Docker desktop. Here you can see. You will be going to enable with your Docker file, right? Expose. And whenever you are running here at the local, all the images, if you let me go to another container, and here you can see, it's giving you run instruction, and here you can see 8081, 8081, 808, 8081. According to the plus one, it is going to add. If I go to another one, so 8082, like that it will add a random port to your container and trying to access over your local host. Okay, if not, then you can specify the particular port number and then you can run it. If I click on this, I don't want that, then uh, inspect. It's run logging into your container. See, this is you logged into the container. All the files, these are the code files and system files, and this is about the stats, CPU utilization, and all of your container. Okay, let me stop this all since it is going to use my laptop CPU. Stop them. So we'll discuss, we're going to run some real kind of applications and we'll discuss in coming. Today we already 11:10. This it's going to be a long session again. Let's cover from tomorrow onwards. So who are all not registered, go and register to get the class link and all, and to get added into the classroom. You can keep this server. I'm just going to stop this server. Let's continue from tomorrow onwards. please have an eye on the classroom, and from now onwards I'll going to add assignments at the project dashboards. It's very important from now onwards. And who are all not attended yesterday's class, just please go to YouTube and find out. Simple, go and download just this one. Download Docker desktop. That's it. It's just exe file. Click on this, install Docker Windows. If you click on this, it will download and give next, 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 next. That's it. Okay. Okay. Thank you, everyone. Thank you very much. Let's discuss Docker is not in EC2 also in the real time. Docker is a runtime as part of your Kubernetes cluster. You will not install specifically anywhere. For your development staging, or your developer wants to do something installation, they'll request for a server to create and install the Docker, and then they can run it. So normal development issue. But while you go towards the production, no, you can't keep the Docker one server separately and running Docker, and that container is running the business application. No, it is not the case. So don't believe all this. It will be always your Kubernetes cluster from in this trend DevOps. Thank you everyone. Thank you very much for joining the session, and we'll continue from tomorrow onwards at the same time.